Guys, welcome to some more A-level maths revision. Today we're taking a look at some year 1 material and we're looking at solving equations with logs and exponentials. So not a massive part of the chapter, but very important, especially if you're going on to do maybe even A-level further maths. Very, very important. So let's jump straight into this, see what we've got today. So the first question here, we want to find the exact solutions to the equation given in the question here. So let's just rewrite our expression just a tiny bit. So we've got e to the x plus 12 e to the minus x. Now e to the minus x, we could write that as 1 over e to the x, because it's 12 times that would be 12 over e to the x, right? So that's what we've got here, and this is equal to 7. Okay, now to make life easier solving this, we can times through by e to the x. So we times everything by e to the x. Well, e to the x times e to the x, that's going to give me e to the 2x, just add in the powers, x plus x, we get 2x. This will just become 12, and this here will be 7e to the x. Okay. Now at this stage, what we'd hope for here is that we're going to get a quadratic. And if you notice, we could write this as e to the x all squared. Okay, so you could use e to the x squared like that. Okay, so we can obtain a quadratic here. So if we make this equal to 0, this equation, we should be able to factorise this quite nicely. We hope. So e to 2x minus 7e to the x plus 12 is equal to 0. Now, they won't necessarily always factorise, but quite often with these questions they do. But if it doesn't factorise, you'd have to just use the quadratic formula. So this is our expression here. You can, if you really want, to use this as a quadratic. If you substitute, for example, u or y in. I don't think it's necessary, but I will do it for a later question. But I won't do it for this one. I'll just carry on like I would anyway. So this is e to 2x, so if we factorise this now into a quadratic, essentially, the first term of each bracket must be e to the x for each one. That would give us e to the 2x. We need plus 12, but minus 7e to the x. So two numbers that are going to times to give us 12, but also give us the minus 7e to the x. Well, that's got to be minus 4 and minus 3. Okay. If you expand this, you will get this, so everything's worked perfectly. So then what we can say is that e to the x is equal to 4, or e to the x is equal to 3. Okay, just doing each one of these terms separately. And at this stage here, we just need to solve here. So if you've got e to the x is equal to 4, we just essentially need to take logs of both sides here. So this would be ln e to the x. The x would come down to the front, so if I just demonstrate it for one. Okay, like so. The x would come down to the front, so this is x ln e equal to ln 4. And then ln e, you remember, is just 1. So this just becomes x equals ln 4. Okay, so that's one solution. So x is equal to ln 4. And the exact same principle applies here as well. So e to the x equals 3. That means x will just be equal to ln 3 as well. Okay? And there you have it. So that's just our solution for that one. If you really want, you can put it into your calculator and verify that. You will get a 7 if you put the left-hand side in with x being ln 3 and ln 4. You will get a 7. So that's just a nice way to verify it. But I will do, just to finish this off, because we want it in exact solutions. This ln 4, we could write that as ln 2 squared, and then remember the power rule here with logarithms. I can bring this 2 down to the front, so 2 ln 2 there. Okay, that's just a nicer way of putting it, but we can't do anything with that ln 3, so we just leave that as it is. Remember, ln, if you've not come across this just yet, that's just log base e. Okay, so that's just a nice logarithm that we use. Makes life much easier essentially. So yeah, so that's that first question done. Let's take a look at the next one. So the next question here, 2 parts to it. The first one, we want to sketch a graph of this exponential equation, y equals 4 to the x. And then part B, we want to try and solve this equation. So, question 4. So let's try and ignore my shoddy art skills, but we'll give it a go. Like it says, it only has to be a bit of a sketch, it doesn't have to be perfect. So, y equals 4 to the x. Well, remember, this is just an exponential graph. Remember, an exponential graph starts in this quadrant here, and it slopes very fastly up into this quadrant. So it's going to look something like this. Something like that. It should be a bit of a smoother curve, but let me have another go. See if we can make it nicer. Give it one more go. Let's try it. So there, well, that looks a bit nicer. Okay, so that's just a nice little curve there. Y equals 4 to the x. But we need to mark down where this crosses the axes. Well, it never crosses the x-axis, but it does cross the y-axis, like we can see at this point here. So what is that point? Well, that point occurs when x is 0. So when x equals 0, what do we get for y? Well, y is going to be equal then to 4 to the power of 0. And 4 to the power of 0, anything to the power of 0, is just 1. Okay, so it cuts there at 1. Okay, so that's just the coordinates where it crosses the y-axis. So 0, 1 on the y-axis. Okay, that's just part A done. For part B here, we want to try and solve this equation now. And if you notice, this is very, very similar looking to the first question that we just did there with the exponentials. But this time, instead of working with the actual exponentials, we've got this as basically a base 4, but we've got this disguised quadratic, and then we're going to solve it using logarithms. So for this one, I will use a substitution just to demonstrate both ways of doing it. So 4 to the 2x, we could write that as 4x squared. Okay, that's the key point here. Now sometimes they'll tell you what substitution to use. This one they don't, so you've kind of got to figure that out yourself. And that substitution is going to be this here. So if I just say let u equal to 4 to the x, well, we can rewrite this quadratic that they've given us. So this now is equal to u squared, because that's u and we square it, so u squared, minus 10 lots of u plus 16 is equal to 0. Okay, so we've just got this quadratic here, and in fairness it does look a lot easier than starting off with this quadratic, but you will end up with the same answer either way. So all we've got to try and do now is just factorise this. So it's going to be u again equal to 0. We need positive 16 but minus 10u, so we can have minus 8 and minus 2. Okay, that gives us this expression here. Good stuff. So at this point here, we can just simply see what u is basically. So u is either 2 or u is equal to 8. Okay, so remember u is actually 4 to the x. So what we're saying here, if we do it up here, is that 4 to the x is equal to 2, or 4 to the x is equal to 8. Okay, and then at this stage here, we just need to solve this using logarithms. There is another couple of ways you can do it. You can consider the base, for example, of a logarithm and other methods like that. But I think taking logs is a much nicer way of doing this. So if you take logs of both sides, that's ln 4x, sorry, ln 4 to the x is equal to ln 2. If you bring the x down to the front here, that'll give us x ln 4 is equal to ln 2 still. And then divide this side here by ln 4, so do the same to this side to get x. So ln 2 divided by ln 4. And if you put that in on your calculator, what you will get is you get 1 over 2 for that one. So 1 over 2. And then for this one here, so 4 to the x is equal to 8. Again, exact same method as this one here. So ln 4 to the x is equal to ln 8. Bring the x down to the front. So it's equal to ln 8, and then divide through by ln 4. Okay, put that on your calculator, and what you'll get there is 3 over 2. Okay, and there you have it. So that's both your solutions there. So x equals 3 over 2, and x equals a half there. Okay, both our solutions for that question. Next question, pretty similar again. You know, the idea is just to practice the key concept of logarithms. So for this question here, you need to be confident with the idea that if you're subtracting a logarithm with the same base here, then we can write that as a single logarithm. So how do we write that as a single logarithm? Well, because we're subtracting, we can write that as division or a quotient. So it's going to be just one logarithm with this base here, 2. It's going to be x plus 10 as the numerator, and then x minus 5 as the denominator. Okay, and this is just equal to 4 still. This is just the exact same expression. We're just putting it as one logarithm. Now we need to consider essentially anti-logging this. So what you're doing here is you're raising everything to this base. Well, this side will just cancel. Essentially, it's the inverse. All I get left with is x plus 10 divided by x minus 5. And then this side, we're going to raise this, but the base will be this base here. So this is essentially 2 to this power. So 2 to the power of 4. Okay, which is 16. So what I've got now is x plus 10 is equal to 16 lots of timesing this through here. Because all we need to now is just solve this. Okay, multiply this out, so you get 16x minus 80 is equal to x plus 10, and then just solve here. So this is going to be 15x is equal to 90, and then divide both sides by 15, so you get x equals 6 there. Okay, so like you can see, not too challenging. Just make sure you're confident with all the rules of logarithms. If as long as you've got the basics and with the laws of logarithms, you should find this quite a nice chapter. Okay, and this next question here, this is quite common with these logarithm questions. You'll be given some working that our students apparently done, so we've got to spot the error in their working. So that's the first mark here. Can we spot can we identify the error? So let's just follow it step by step. So for the first line of working, let's just do it in black pen. So for this line here, all they've done is they've brought this minus a half to the top using the power rule, and then they've wrote that as the power. So if you bring that that half to the top here, that's just the square root, so that's fine. Next line, they've done x minus the square root of x plus 1 is equal to 2 to the 1. So this is where we run into our first, well, I think it's the only error, but this is where there is an error. The 2 to the 1's fine, because that's what it would be raised to, so it's 2 to this power, so that's fine. But this here, this is an error. So this should be x over, so it should be x over, like that. Okay, this is where they've made the error here. So this is an error, it shouldn't be like this essentially. Okay, so it shouldn't be this, it should be this. Okay, but we can use that now to carry on with this question. So the error in line 2 should be dividing rather than subtracting. Okay, so that's just the error there. And then for part B, if we want to solve it, well, we can start with this bit here that I've just jotted down. But if we write it out in full, so this is log 2 of x over the square root of x plus 1, and this is equal to 1. Okay, so I've just done the power rule here like they've done for the x plus 1, but I've put it as a single logarithm now. Okay, anti-logging this now, we get x over square root of x plus 1, this is equal to 2 to the 1, so just 2. So just like they've done, or they tried doing, but this is the correct bit now. So here now, if we times through by this denominator, so we get x equals 2 lots of the square root of x plus 1. Okay, and this is where a lot of students might find this question somewhat challenging to carry on with. Try not to be put off of it. Remember, we need to solve this equation completely. Now with there being x here, but there's an x on this side, it causes a bit of an issue. So what I'm going to do here is square both sides to get rid of this square root. So x squared is equal to, so if you squared this side, that'd be 2 squared, so that'd be 4. And then this would be x plus 1, but they need to times them together, so it's 4 lots of x plus 1. So in other words, x squared is equal to 4x plus 4. Okay, so if you notice at this stage now, we've got a quadratic. So what we're going to hope is that we can either factorise it, and if we can't factorise it, we'll use the quadratic formula. So putting this in terms of being equal to 0. Okay, so that's all equal to 0. Now the issue is here, with this one, we unfortunately can't factorise it, so we will need to use the quadratic formula. Okay, so let's just get rid of some of this rubbish. We should have enough room, I think. Get rid of this as well. Okay, so if we carry on with it, so x squared minus 4x minus 4 equals 0. So if we solve this using quadratic formula, so using the quadratic formula here, x is equal to minus b, so minus minus 4, so that's 4, plus or minus the square root of b squared, so 16, minus 4, times a, which is 1, times c, which is minus 4. Okay, we divide this by 2a, where a in this case is 1, so we divide it by 2. And then at this stage here, we just need to start simplifying. So x is equal to 4 plus or minus. In fact, if we just do it in one step here, in fact, we'll write it down and be indecisive. So this will be 16 minus, so this will be minus 16, so that'll be square root of 32 over 2, which we could write this now as the root 32 here. So that will be root 16 root 2. So we could write that as 4 root 2. Okay, so this is 4 plus or minus 4 root 2 over 2. And then we can actually simplify that, just dividing this by 2 and this by 2. It's being 2 plus or minus 2 root 2. Okay, but we just have one slight issue here, so you've just got to be careful. With logarithms, remember, a logarithm can't be negative. Okay, if you do 2 minus 2 lots of root 2, you end up with a negative answer. Okay, so we get rid of the negative one, the negative solution, and we just have x equals 2 plus 2 root 2. Okay, so final answer is just x equals 2 plus, oh my god, I'm having a nightmare. Let's erase it. So x plus 2 root 2 here. Okay, and then that's our final answer there. So like you can see, they won't always factorise nicely, but just go to your quadratic formula, you should be confident with it. Just plug everything in and just solve like normal. But just be aware of that fact, we can only have a positive solution here, okay? Just because we have the minus here doesn't always mean that this will be negative. Obviously, 2 minus 2 lots of root 2 will be less than 0, so we have to omit that solution there. Okay, and then moving on to the final question here. We've got two parts to it. We've got one just involving ln, and then the second one is in terms of an exponential. So these questions are actually taken off one of the old exam papers. So pretty standard exam type questions here. Ln x plus ln 3 being equal to ln 6. Well, again, using your laws of logarithms, the left-hand side we can combine as a single logarithm. So when you're adding, we're multiplying here the 3 and the x, so we get ln 3x. And this is just equal to ln 6. We haven't done anything with that. And now at this stage, with these being logarithms, essentially the logs we don't have to actually worry about, because all we're saying here is that 3x is equal to 6. This is the only part we're concerned about. We're concerned about that and that. So 3x equal to 6. So we're just solving this. Divide 3 by 3. X must be equal to 2 there. Okay. You know, this is quite a long way of actually showing it. Obviously, if you know your laws of logarithms, x must be 2 instantly. 3 times 2 gives you 6. That's just, again, practicing the laws. But just so you've got full detail there, x equals 2. Okay, and then part B, very similar to the first question we did here. E to the x plus 3e to the minus x is equal to 4. Again, this is 3 over e to the x, so first step we're going to do is multiply by e to the x. So that's e to the 2x plus 3, and this is equal to 4e to the x. So subtracting 4e to the x off both sides, plus 3 is equal to 0. Okay, and at this stage here, we're gonna hope, fingers crossed, that this does factorise. So if we do try it, we do find that it's factorises quite nicely. So this will be e to the x. So again, don't forget both of the brackets must start with e to the x. So e to the x, we need positive 3 and then minus 4. So like you can see the pattern's the exact same again, both minus. Okay, this is quite common, but not always the case, so just be slightly careful, but more often than not you'll find both are negative. And then we just need to put them both in terms of e to the x. So therefore, e to the x is equal to 3, or e to the x is equal to 1. Now instantly, one of these, you should be shouting the solution out. So for this one, hopefully you can spot the solution straight away. Remember, a power where the answer is 1, what's that power got to be? Well, that's just got to be 0, right? Anything to the power of 0 is 1. So for this one, x is just simply 0. So like 1 gives us that one. And then for this one, just like we did before, if you take logs of both sides, that's ln e x is equal to ln 3. Bring the x to the front. And then this ln e here is just 1, remember, it's essentially just cancels out. So you get x equals ln 3. But you don't have to show these preliminary lines of working here. It's just to make it a bit clearer. But as long as you can get to this final solution here, x equals ln 3 and x equals 0, then you're getting your full marks. So that brings us to the end of this one, end of this video. I hope it's helped, hopefully not too long. But if there is anything unclear, anything or anywhere I've made a mistake, please just let me know down below.